kids know what this is. This is me reading the book. I mean, if you want to go shopping for a volcano in the United States, this is where you're going to look. On the West Coast, you see the art. It looks like there's somewhat on a line. The idea we're going to present today explains why we have volcanoes in a line and why some other things go on. In 1987, we had an earthquake in Whittier that was 5.9 on the old Richter scale. Pretty juicy quake. It woke us all up. When Mount St. Helens blew, way in Washington, 1 week after that, down at Mammoth Lakes, they had at least 4 earthquakes that were that were greater than 6 point something on the magnitude scale. So they had even larger earthquakes than the Whittier one. 4 of them within a day, right after, 1 week after this thing blew up. Is there a connection to it? We think so. We think this play explains the connection and other things along with it. Okay, we'll get into this. Ready? So, we're here because things are going on the planet, and we have an idea that helps to explain it. The idea is going to be presented by the Victorian players who are proud to present the drama of plate tectonics.
In the year 1786, everyone in Germany.
It looks like they fit together.
We are now in the late 1800s in Austria.
This is Gomorrah. This is great.
The year is 1912 in Germany.
Okay, I've done it. My book is done at last. Continental drift, an idea extended from the ideas of Lilico and Seuss.
Thank you.
Continental drift, continental drift, continental drift.
But why do you think that? Tell us the reason.
First reason, climate, because of climate there are the same trends as tropical climates here and here.
Is that all?
Oh no, the animals too.
Is that all the evidence?
No, there is one more. Surface features and glaciers.
Now what happened?
They drift apart, see? This is Gondwana land. They drift apart. This is Laurasia, and this is Pangea.
That's good. I like it. What do you think?
Ready?
Yes, I like it.
So now everyone likes the idea of continental drift.
Now, just wait a minute. I studied the forces of the earth. Guess what force was strong enough to move those continents?
Well, maybe the...
No.
One more time. Ready?
No.
Better.
Well, maybe we need to find out more about this continental drift.
But what force could move the continents?
Many scientists like this theory, especially those in the southern continents. But some scientists, those in Europe and North America, say
No.
One more time, please. I'm sorry. Ready?
No.
Good. Thank you.
Poor Alfred, the scientists began to laugh at this theory.
Ha ha
The ocean floor is flat. Sediments from the mountains be carried into the ocean. They are laid down flat.
Now it is World War
When we use submarines, we go find enemies, ships, and things. Then we, without knowing it, it works.
I'll work on that, sir.
The sonar was successful in installing on our ship.
What if this sonar is sure that we are left? We just found out we were just 10 fathoms away from the bottom, and there were no mountains there. We turned just in time. It's a good thing that we have it.
I wonder what the ocean bottom really looks like. There are reports from the cities about mountains being down there. I'm going to map the ocean floor. Well, this is interesting. It isn't flat.
Not that.
No, it isn't. Just look.
California.
We now know that the ocean has many
But what could make that happen?
Well, maybe.
Let's study it some more.
This is really amazing to the scientists. It really made them rethink their older view. The ocean floor is so much younger than the land from which they thought it was, formed. Wonder how they will solve that problem.
Look what happens to the magma when it begins to rise in deep areas of the crust. As it rises, it reaches the crust. Then it begins to cool and harden. As new magma comes up, it pushes the old stuff to the side. The old magma is pushed to the side and then becomes cool north and sinks back into the magma. This then changes and goes into deep currents.
How about that? If that happens, looks like maybe the ocean floor also changes. As the magma rises up and reaches the surface, well, actually it reaches the ocean bottom and then gets pushed aside. It seems like the ocean floor is spreading. Wait a minute, let me try that again. The magma rises up, cools, and then hardens. New magma rises up. It pushes the old magma to the side. This old magma must be part of the ocean floor. I need to tell others about this.
What is this news? I don't believe it. The seafloor is spreading. Just a minute. I need to find out more about this.
Seafloor spreading.
Fantastic. It could be seafloor spreading. Very, very interesting.
This theory was readily accepted by the scientists. After all, it did help explain the difficult problem with the different ages of the sediment and the land and ocean. Just 3 years later, in 1962, scientists discovered that in the ocean floor and another new discovery. Let's listen to the oceanographer and find out how they work.
I was studying the magnetism of the ocean rocks, and I found this type of pattern on the ocean floor due to the magnetism. Notice how the stripes look. They make a pattern. Both sides of this ridge are identical to each other. So, you ask, what about it? Well, the stripes are really the direction of the magnetic alignment of the minerals in the rocks. The minerals, while cooling from the molten state, out in the direction of the magnetic north.
But they don't point at the same direction.
That's right, here and here. North as we know it was actually in the south.
I don't understand.
I don't either, but here are my experiments and notes for your, please see them for yourself.
You're right. There are magnetic reversals in the rocks on the ocean floor. I wonder how that could have happened.
Well, first, there's probably a bit of a mystery for scientists. They have yet to figure that one out. Maybe someday you will solve this one.
Then,
No, not Michael.
Listen,
then this really
she's never had this
could
part before, so.
then this really could explain how the continents drift. Alfred Wegener was right after all.
Say go.
Go.
Again, she had no idea she had this gonna happen. Professional help with that, that's great.
See, he was right. Here's the long-awaited proof. Convection current sea floor spreading magnets, like matching planets, plates, and fossils on wildly
Separated.
separated continents.
Okay, you have shown me the force that could have made a continent move, but Now, my overzealous friend, another question for you. How can continents have moved if they go from the surface and extend down into the crust? Or do they extend all the way into the mantle?
Oh man, can't you give us a break?
No, I'm sorry, I can't. Ideas of science must answer all the questions before it can be accepted as a theory.
Meanwhile, we have had several earthquakes. Let's look over here to where this person called seismologist is studying. We study the earthquake waves that are released by quakes themselves. There are patterns in them too. The waves respond differently to different materials that they place from. We know that they have one kind of pattern when they go through solids like the bedrock and another pattern. When men go through liquids like in the ocean, we have just discovered a different pattern. It is about 60 miles per day circles. It appears by recording that it could be a soft continent.
That's it. That's really it. That proves it. That proves it. The continents extend down only to the plastic-like layer, not into the mantle completely. They could move on this plastic-like layer. Hooray, old Alfred. I knew you had to be right all along.
Well, sort of right, but not completely. Alfred was brilliant for his time. We just didn't realize that until now, but there is still one major flaw in this theory, and it needs to be corrected.
A flaw? What now? But tell me quick, because we can solve that too.
It just wasn't the continents that drifted. The entire world is moving. The land under the ocean is moving or drifting as well as the continent.
Yes, that's right. I know that too. But good old Alfred.
Miss the whole picture. The land, which includes the ocean floor, is like well on plates. These plates are all moving in different directions and at different speeds. That's it. This is the theory of plate tectonics. Plates are the sections of the crust that move. Tectonics come from the Greek word meaning to build. The plate tectonics refers to a theory of how the surface of the earth is built from the plate.
This marked one of the great events in history of science. Not only did all disciplines of science accept this theory, they were all affected by it. But until very recently, there was no indirect evidence that all the plates were actually moving. Think for a minute, which group of scientists actually were the first to record this theory?
Okay, she's asking which group of scientists actually recorded, measured, physically measured the idea that the continents had been moving apart from each other. And before we just had indirect evidence was seismologists, biologists, zoologists, archaeologists, chemists, physicists, geophysicists, nutritionists, psychics, whatever. Maria? Yeah, they asked what was things like quasars. Hang on a second. Quasar is a very bright object out in space. In fact, it's brighter than galaxies at times. We don't really know what a quasar is, but we do have people looking at it, and they were looking at it from 3 places: from Boston, Massachusetts, from Germany, and from Sweden. We had observatories would time how much, would write down how much time it took for the energy from the quasars to get to the Earth, into these 3 different laboratories. And it turned out that that time was changing, which meant these positions of these things on the Earth must have been changing. And from those measurements, you're able to find out something that's going on. Now, if you were to make a map, if you were to plan a trip of flying an airplane from North America to Europe based on this map, then you would be off by a little bit, because this map is at least 20 years old. And the measurements, the actual measurements they found out from quasars is that, it's a pipe, guys, is that this continent, this whole piece of real estate here is moving this way about 2.5 inches a year. Show me 2.5 inches, that's 1 year. Then another 2.5 inches. Then another 2.5 inches. So if this map is 20 years old, it's 20 times that, or about 40 inches off, near 4 feet off. So if you were to gas your airplane, according to this map, When you flew over there, you would fall 4 feet short of the runway because this map is incorrect. This is just ink on paper. We're putting ink on the paper as different colors. It's like that. That's nice. But you live on something that's moving. And what's moving? The entire continent this way. Okay? We have some things to show you also. Oops. That we'll go ahead and read the last paragraph, nice and loud. Again, please be loud. Yeah.
This marked one of the great events in the history of science. Not only did all disciplines of science except system theory, they were all affected by it. Until very recently, there was only indirect evidence that the plates were actually moving. Think for a minute. Which group of scientists actually were the first to record this movement?
Get ready to do that, so go on. Last paragraph. Thanks for coming. In any case, we have some other things to show you. Don't worry about the wheels going through. If you think about the ocean, the bottom of the ocean, yes, if you look at the ocean, the bottom might be flat. No, we've seen what it's like. It's not exactly flat at all. Remember, submarines have no windows. How would you like to have to drive your submarine around through this particular condition? Here you see what the land looks like above the water. This is what it actually looks like from my line. Okay, that's the water. You know your part. This is what it looks like below the water. The reason we have volcanoes, where we begin with volcanoes, the reason we started talking about mammoth lakes in the first place is because plate tectonics explains why volcanoes get made.
The tectonic drama begins in the 5-mile-deep ocean trenches that ring the western Pacific. Here, the westward moving Pacific plate sinks beneath Asia, beginning a complex and violent journey back into the hot interior, a process called subduction. As the plate that was once Pacific seafloor dives some 50 miles beneath Japan, it begins to melt. From this subterranean destruction comes new land as hot magma rises to fuel Japan's many volcanoes.
Well, I think that's what's actually going on here. The Pacific plate is subducting somewhat. This stuff is melting. And it's a lighter material. You can tell it's lighter because it's already floating on top of whatever the metal is. So we're going to put these two together, sort of, somehow. You can see how this is the edge of the plate right there. These are a string of volcanoes. Here's Mount St. Helens, here's Mount Rainier, here's Mount Shasta, Mount Lassen, Sutter's Butte, and then maybe Mammoth Lake's down this way. Who knows? We'll explore more. Did I tell you the warnings right now? Mammoth Lake is at green. They consider to go to yellow over the weekend because of the number of earthquakes. Orange means eruption is imminent, and red means you've got a volcano. Red means you've got lava pouring out. As far as Mammoth Lake goes, this whole area is called Long Valley Caldera because it was once part of a volcano. That is to say, this thing blew up about 700,000 years ago, and when it blew up last time, it sent pieces from California as far away as Nebraska, so that'd be right around in here. So it might send material all the way around here. So if Mammoth goes big time, could be a concern for us. Right now, it doesn't look like it's going to go big time at all. We've gone from green to yellow. A yellow event happens about once every decade, so it's no big deal, but still, it's certainly of some interest to us. One more thing is plate tectonics. The idea of the plates moving explains why we don't have mountains here just equally, one mountain in every state. We have mountains where mountains show up. And this is where they show up on the planet. Like we're having some datum tectonics right next door. have these things here, one more thing, so these are, of course, what? Seashells. Where do you normally find seashells? At the beach, the bottom of the sea, right? Except we found some examples of seashells. Who's my class now? Erica? And show these to the guests. These are examples of fossils. And you can find fossils of seashells not down the bottom, but you find them at the highest points of the world. You find them on Mount Everest and all the Himalayas. So the Himalayas must have at one time, did at the bottom.
Situated by the Himalaya Mountains. Here, 29,000 feet above sea level, fossils of ancient marine life are preserved in the rocks. They tell the remarkable story of another plate boundary where continents collide. More than 40 million years ago, the northward movement of the plate carrying India crashed into Asia, and the Himalayas were born. Sea rock on the leading edge of India was pushed to the roof of the world. Here, the former island continent is thrust under Asia, creating the Tibetan Plateau, the highest average landmass in the world. Today, the impact continues, pushing Mount Everest ever higher.
So it's the highest now, but at one point it was at the bottom, being that part of the sea. Bottom part of the sea. I love this because it used things like this. Ta, everything ta. One more time, ta. DVD is probably just as well. But that ends our production. Thank you, Tony. We have seashells at the top of the world. While you have earthquakes, we have earthquakes and volcanoes. We have volcanoes. And that's the first area that we all watch. Okay, that's it. Everybody give yourselves a hand and applaud. And that's it.
Say hi. Jeez, man.
The production of it.
There's a production, it's a play. Whoa, I see that little thing over I don't see anything.
His name is Suriel. His name is Suriel.
That's cereal.
No, he's cereal.
No, that's Marco Polo and cereal.
Hey, cereal, where's the milk? Sugar. We could have breakfast,
Next class. Okay, seats please. Let's go over the test.